Construction of a grouped frequency distribution. Number 1. Determine the maximum and minimum value of the variate in the data. This difference is called the range. Number 2. Decide upon the number of classes to be formed. These should lie between 5 and 15. Number 3. Put tally marks against appropriate classes. Number 4. Count the number of tally marks in each class to get the frequency of that particular class. Number 5. Check that the total of all frequencies is the same as the total of all observations. Number 6. Write a suitable title of the frequency table. For example, marks scored by 20 students are given as 57, 84, 53, 89, 57 and so on. Make a good frequency table with one class being 70 to 80. The minimum marks in the whole group are 41, the maximum are 89. The range, which is the difference of maximum and minimum, is 48. Let us make classes of width 10. So first class will be from 40 to 50, then second 50 to 60 and so on up to 80 to 90. We put the tally marks in the corresponding classes. In the end, we count the frequencies which come out to be 20 and it tallies with the number given in the whole data. Graphical representation of data is histogram. Histogram. It is a graphical representation of a frequency distribution in the form of rectangles with class intervals as basis and heights proportional to the corresponding frequencies. All the rectangles drawn are adjacent to each other. There should not be any gap between any two rectangles. If the lowermost class does not start from 0, a kink is used. For example, weights of 40 persons are given below. Weights include lengths 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90. The number of persons corresponding is 8, 10, 6, 9 and 7. We use a kink because the data does not start from 0, it is quite away from 0. Now, there are 5 classes and 5 rectangles in the figure, which makes a check of the given data. Pictorial representation of data is pie chart. Pie chart. It is a pictorial representation of the data by using sectors of a circle such that the angle of each sector is proportional to the magnitude of the data. For pie chart, central angle of any item is the value of the item divided by sum of all the items multiplied by 360. For example, expenses of a household are given below. Item, clothing, food, house rent, miscellaneous. Amount spent in rupees 1200, 2400, 7200, 3600. Represent this information in the form of pie chart. Now we arrange the given data in the form of columns. The first column stands for items like clothing, food, house rent, miscellaneous. Second column stands for the amount spent on each item, which is 1200, 2400, 7200, 3600. Third column stands for the central angles corresponding to each item, which come out to be 30 degree, 60 degree, 180 degree, 90 degree. The total is 360 degrees. The whole data in the form of sectors can be represented by drawing a circle. First of all, we draw any radius like OA, then mark the corresponding angles for each item. For example, for clothing 30 degree, for food 60 degree, for house rent 180 degree, and for miscellaneous 90 degree, which makes a complete cycle of the angles. Probability. Some terms related to probability are defined below. Experiment, an operation which can produce a well-defined outcome. For example, tossing a coin, throwing a die. Random experiment, an experiment which when repeated under identical conditions does not produce the same outcome, is called a random experiment. For example, tossing a coin, throwing a die. Elementary events, an outcome of a random experiment is called an elementary event. For example, the outcome of tossing a coin, the result of throwing a die, both denote elementary events. Compound event, an outcome obtained by combining two or more elementary events, is called a compound event. For example, the outcome of throwing 2 dice, the outcome of throwing 3 dice, and so on. Probability of happening of an event is equal to favorable number of elementary events divided by total number of elementary events. The probability of an event E is represented by PE. So we have PE is equal to number of favorable elements upon number of exhaustive events. For example, for any event A, we have PE plus PA, E bar is equal to 1, where PE represents the probability of E happening and PE bar represents the probability of non-happening of an event E.